Find Laplace transform of f of t equals cosh at. We're going to change the t function into s function. So Laplace formula or Laplace equation is equal to 0 to infinity e to power minus st times function of time f of t dt. We can write cosh at in terms of exponential function. That's a half e to power at plus e to power minus at. And so we can replace the f of t with the cosh of at exponential function. Laplace cosh at will be equal to the integral 0 to infinity e to power minus st times dot a half open bracket e to power at plus e to power minus at dt. We need to expand the bracket now. So expanding the bracket, will be equal to a half integral 0 to infinity a half e to power minus st times e to power at plus e to power minus st times e to power at minus at dt. And I need to write a half integral 0 to infinity in terms of indices form e to power minus st plus at. So we're adding the power, we're adding the exponent, plus e to power minus st minus at dt. And that will be equal to integral 0 to infinity e, we're taking minus t out in both cases, minus t open bracket s minus a plus e to power minus t open bracket s plus a dt. And we now need to write integral a half integral a half bracket because square bracket because we're integrating first. Integrating exponential function, you get exponential function back, and then you divide it by differential of the derivative of the exponent. So the derivative of the exponent in this case is minus open bracket s minus a plus e to power minus t open bracket s plus a. The derivative of that will be minus s plus a. We're going from 0 to infinity. And equal to, well, we got a half. So I want to split it up now. Bring out the denominator. It's a constant, 1 over s minus a, which is minus, open bracket, that's 1 over e to power, the t is infinity, open bracket, s minus a minus e to the power 0, because t is 0, we substitute in the boundaries. Again, minus, that should be plus, we'll put it later, minus s plus a, open bracket, that would be 1 over e to power, that would be, well, infinity, open bracket, s plus a minus e to the power 0. And equal to, we got the a half square bracket minus 1 over s minus a, open bracket, 0 minus 1, because 1 over infinity is 0 and e to the power 0 is 1, minus, open bracket, minus s plus a, that's minus, open bracket, 1, that's 0, 1 over infinity is 0, minus e to the power 0 is 1. A square bracket. And that Laplace of cosh 80 is equal to a half, open bracket, minus 1 times minus 1 over s minus a is 1 over s minus a. That should be plus. I better change that. That's plus, plus, and plus 1 over s plus a. Now we got to make same denominator and multiply the denominator together and cross multiply. So if we cross multiply, we get s plus a plus s minus a, open bracket, close bracket, divided by difference of two squares, s times s, that's s squared minus a squared, and that will be, then we can simplify that. So a half s, that will be 2s, the a minus a cancel out, so a half 2s over s squared minus a squared, and the 2 cancel out, so we get s over s squared minus a squared, and that will be the Laplace of cosh 80. So that will be the derivation for that. So we can put that in a box. Now we could do an example. Laplace of cosh 3 cosh 8t will be equal to, well, 3 is a constant, so to bring that out, and a is 8, so we'll go 3, the constant, and then we'll go s over s squared minus 8 squared, which is 64. So that would be 3s over s squared minus 64. That would be Laplace of 3 cosh 8t.